All right, and welcome to Composite Area with Autograph Level 2. Now, in example 1, we want to find the area of this very funky shape below. You could almost say it looks kind of like a sock. That's what I would describe it as, or a shoe. And kind of like in our very last video, we'd ask ourselves, what's our first step? How do we want to tackle this? What do you think? And I think the best thing we can do is we can actually divide this up into different shapes that we are familiar with. Now, if you will recall, you have your choices of either drawing horizontal or vertical lines based on the information we're given. In this case, I think a vertical line is still our best bet. So I'm going to draw that, and let me go ahead and start sectioning these off in different colors. So the first thing I want to tackle is this very obvious rectangle. And the reason I want to tackle that first is because we actually know its height and its base. We can go ahead and solve for that. So what I'll do is I'll write the area of a rectangle. We know that is base times height. Of course, in this case, the base would be 4 times the height of 12. We see that right there. And we know that 4 times 12, we can use our calculator, is going to give us 48. And of course, in this case, inches squared. And there is our first area. If you'd like to keep track of that, I would highly recommend writing it on the inside, because that's what the area is. It's all that space in the inside. Now let's go ahead and choose a different color. I really do like this nice little magenta right here. And we're actually starting to run into a problem. We don't know this length or that length right there. So what can we do? Well, what we want to do is we want to say, hey, we know that this entire length is 12, and we know that this little piece right there is 6, and whenever we know the total, we can always subtract away the piece, and so 12 minus 6 would equal 6. So it turns out this has a height of 6. Now, not only does it have a height of 6, we can also find the base. And once again, we know that if this entire line right here is 8, and we know that this piece way up here is 4, well, once again, we can do 8 minus 4, and that would give us 4 for right there. So when I look at this rectangle right here, I know that from 12 minus 6 being 6, we have sides of 6 and a side of 4. And so I can go ahead and say, all right, well, the area of my second rectangle is still the base times the height, which of course would be a base of 4 times 6. Well, what is 4 times 6? We know that that's going to give us 24 inches squared. Now this next part's actually going to be probably the trickiest. And let me go ahead and switch to my teal color here. And so we're actually going to find the area of this half circle. And an even better way to describe it is we can call it a semicircle. In fact, let me go ahead and write that down. This is our semicircle. You can always think of it as half a circle. Well, the first thing we have to know is, what is this entire line? And it stands to reason that if this was 6, then this must also be 6. And so we know that basically that's the diameter, but we don't need the diameter. We need the radius. Basically, from the center to the edge of this semicircle, how long would that be? And we know that the radius is always half the diameter. So if our diameter is 6, well then of course our radius must be 3. And now we actually have enough information to solve for the area. So let's go ahead and write the area of a circle is pi r squared. We can get that from our formula chart or from memory. And so we'll simply write pi, and in this case our radius was half of 6, which wound up being 3. So we'll write 3 squared. Now, we know that 3 squared is actually 9, and so it turns out our area for the full circle would be 9 pi, and notice how I started to block it off. Well, that's not entirely correct. Ask yourself, is this a full circle, yes or no? No, it's half a circle, and since it's half a circle, we actually have to divide by 2. Okay? And so I'm going to draw an arrow from the semicircle to the 2, understanding that's why we're dividing by 2, because the semicircle is half, of the full circle. And so we know that 9 divided by 2 would give us 4.5 pi, and in this case, inches squared. Well, now that we have these three areas, we have the 48, the 24, and the 4.5 pi. With composite area, we want to add them. So let's go to our calculator. Let me go ahead and pull that up real quick. And it turns out that 48 plus 24 is 72. And then we're going to have to add, let's see, so we know that's 72 plus the 4.5 pi. Let me figure out what that is real quick. Oh, and 4.5 pi was 14.13, so plus that 72. And it turns out when we add this 1, 2, 3 things, we'll get the composite area is 86.14 inches squared. And that will be our final answer. Well, I hope this helps, and I will see y'all in our level 3 video. Okay, now for example 2, we have this very funky shape, and this really resembles problem 4, because I kind of like this one, and we'll see why in just a second. Now we see this shape, it's clearly made up of more than 2 shapes, and so we know that we want to start by dividing it up. Now once again, you have your preference. You can either draw vertical lines, or you can draw horizontal lines, and it really doesn't matter in this particular example. And so what I would like to do is I would like to draw 2 horizontal lines. I think it makes more sense to make these long rectangles and go from there. So let's start by divvying these things up in different colors. So I'll pick this very top, let's pick this bottom rectangle. That'll actually be our easiest. And the reason I say it's the easiest is because we already have the height and the base. So let's go ahead and write that out. So we have the area of our rectangle is equal to the base times the height, where here our base is 10 times our height of 2, and we know that 10 times 2 would give us 20. And in this particular case, 20 inches squared. Now there's our very first area. So let me go ahead and write that in, 20 inches squared. And once again, what is area? It's just all the space on the inside. Okay, let's move to our second one. Let me move to my second go-to color. And so now we have this second rectangle. And still, not too bad, not too bad. We know that it has a height of 3. So, let me even go ahead and fill that in. We know the area of our second rectangle is the base times the height. We don't know the base, but we do know the height is 3. Of course, that'll come in handy in just a moment. Now, let's take a look here. We know that this is the base, and this base is actually a piece of this 10. And so what we learned in our last 3 examples is that when the total is 10, we can always subtract off the piece that we're missing, that 2. And so we know 10 minus 2 would give us 8. So it turns out this has a base of 8. And I'm just kind of drawing it on that line, so it's not really in the way or in the middle, but we have our base of 8. So we'd ask ourselves, what's 8 times 3? And of course, that's very good, 24 inches squared. And that's going to be our second area, 24 inches squared. And once again, you can kind of shade all that in just to show that you understand the area is the space on the inside. Now, this is where we actually get to a little bit of an even trickier idea. So let me switch to an entirely different color. Let's go with our teal here. And so now we have this rectangle, and we know that this piece was 4, and we know that this piece was 2, and the entire bottom was 10. And so in this case, if we want to find the base, we actually have to subtract off not 1, but 2 numbers. And so we'll do 10 minus 2 minus 4. And of course, we know that 10 minus 2 was 8, and 8 minus 4 is 4. And so it turns out this is actually not a rectangle, but if the base length and the height are the same, this should actually be drawn as a square. Let's still go ahead, so let's go ahead and write that. We know it's the area of a square. You can still write that as base times height, though. It doesn't change. And of course, we have 4 times 4, so 4 times 4, and we know that that is 16 inches squared. Now, it's my fear, my concern, you might be a little confused. How do we get that 4? Well, once again, we know that this whole line is 10. You take off 2, you get this whole line, which is 8, and then you take off this piece of 4, and you have 4 left over. So that's where we actually got that base, was by subtracting off this 2 and that 4. Now, let me go ahead and write this in here, 16 inches squared. And this actually brings us to the most difficult part of the problem, dealing with this semicircle. And this one's actually even a little bit more complicated because we don't know the length of the radius right off the bat. Let me go ahead and, you know what, I'll go to this red. And let me go ahead and draw that all in red. And let's think about this. I would actually ask you to pause the video and think, can you find this diameter on your own without me telling you? In case you weren't, let's take a look here. We know that this line is really comprised of this height of 4, this height of 3, and this height of 2. And so in order to get this entire diameter, well, we simply take the 4, the 3, and the 2, and we want to add them together. So let's go ahead and do that down here. 4 plus 3, which is 7, plus 2 would equal 9. And so we know that that entire diameter is 9. However, we don't care about the diameter. We care about the radius. And so we ask ourselves, well, what is half of 9? And that's going to be 4.5. So when we go to write our area of our circle, we know that the formula is pi r squared. In this case, we'll actually have pi parentheses, and we know that our radius, not the diameter, but the radius, was 4.5 squared. Now, this is something that, even myself, I need the calculator. And so let me go ahead and pull that up. And let's see, 4.5 times 4.5 would give us 20.25. And then we'll do 20.25 times pi. And it turns out that that gives us an area of 63.62. Now, we're not actually done here. Because, see, this is not a full circle. It's a half circle. So we actually need to take this 63.62 and divide it by 2. And so when I do that, let's see, divided by 2, well, of course, that's going to give us 31.8. And, of course, that's still inches squared. And if you want to, you can write that in there, 31.8 inches squared. Well, our very last thing, and I know this seems like a lot, it is, but we have to take these 4 areas, the 20, the 24, the 16, and the 31.8, and we need to add them all together. So if I do 31.8 plus 16 plus 24 plus 20, it turns out our composite area will be 91.8 inches squared. And of course, once again, that's by adding the 20, the 24, the 16, and the 31.8. Well, I hope this helps, and I will see y'all in our